that we use for people to submit questions, which is www.actualofficehours.com. People can like put their username in, and then they can drop in an image and then hit upload, and it'll get added to the queue. So the queue right now, we only got one question right now from Joshua, so we will work on this. Yeah, Alistair, that's totally cool. Yeah, I look at the Twitch a little bit more than I look at the Discord chat, but yeah, either works. So what we had during one of our streams is someone found a way to basically write a Python script to just bot submissions and just started dumping like 1,000 images of Shrek. Which, I get it. It was fun. It was a fun little, we call this like a pen test. It's like penetration testing in like the hacking world. So he showed me that like, yeah, it's pretty easy to bot your queue to get it to just accept a bunch of stuff. The Shrekening, yes. That is what I get for vibe coding. You're 100% correct in that, yeah, the only problem with vibe coding is security is like non-existent. It's unfortunate. It's unfortunate. Yeah, there is no real security in vibe coding. Unless you tell it to. And that's so what I did. And I'm glad that this happened like early on in the stream. Also that it was just Shrek pictures and not anything else, you know. So, and it was playful, you know. He like apologized. I'm like, no, it's cool, man. I need people to stress test the system. But what I did do after that is I went to ChatGPT and I said, hey, so I need to make this website so people can't like fucking bot it. And so it implemented an IP cooldown ban, so you can't send images less than 30 seconds apart. And then the other thing is you can't submit the same image. So if it detects it's the same like image that's been submitted, it won't let it through. So there is, yeah, ChatGPT doesn't inherently think about security when it's developing things because I guess it assumes humans aren't going to try to break shit. But if I tell it specifically, oh, hey, by the way, I need to fix this so that it can't be broken, it can come up with some pretty decent security features. So, yes, that's why you can't re-upload your same image. Because otherwise people just spam Shrek pics again.
No.
All right, let's see. First question comes from Josh. This looks like... Oh, is this French? Josh is always like, give me French questions. Yeah, if you rename it, you'll have 1 billion Shreks. Yeah, but also they'd have to send it from a different IP address. Otherwise, they'd have to do it every 30 seconds. Also, I put something in so that the queue caps out at 30. So the second you flood it, it stops accepting images after 30. And at that point, I would just tell someone to fuck off or like, you know, like, stop being mean. You could get different pictures of Shrek. I could. It definitely could happen. Okay, cool. So let's see. This is... I need to translate this. This is French. Let's go to ChatGPT and get this to translate. Hat? No, chat. I can see them. Yes, Poison. I can see them. Translate or translate? Which translate is it? Yeah. Un bobine rectangular comporte 22 spire et coaxial. I don't speak French, unfortunately. I have friends that keep trying to get me to speak French, but I already know Italian and Spanish, and like I just don't want to learn another like Romance language. It's just too much. This is actually taking too long. Sorry, dude. Dude, chat 5.1 is like kind of sucking. Here we go. Translate this. I guarantee it'll do this. It'll do this instantly. For whatever reason, 5.1 is just not it these days. Yeah, there we go. Great. See, that's literally all I needed. Is 5.1 like still working on it? I bet it is. Yeah, look, it's still working. Dude, 5.1, what are you doing, bro? Math is a Romance language. It definitely is. I agree. You can call me Dr. G for sure, dude. Yeah. I mean, that's what people at UCLA call me. Because I didn't want to lean too heavy into the Dr. Gold with, like, professional things. They might start wondering, like, wait, why is your name Dr. Gold? Your last name's not Gold. But my first name does start with a G, so Dr. G actually works. So. Oh, you go to UCLA? Nice. Yeah, I taught 5A last spring. I taught 1B this summer. I'm not teaching anything this quarter, but I might teach next year. UCA's dope. Cool school. Gold is AU. Or Dr. AU, Drow, yeah. Yeah. Okay. Nice, Sam. What's up, dude? Good to see you. Yes, I do need to drink water. Can you sign up for my class? Well, I'm not teaching anything right now, but you could have. I literally
taught the yes, we got the baby voice. I literally taught the physics class on YouTube. The summer physics class was online at UCLA, and I taught it on YouTube, and I hosted office hours here on Twitch. It was actually great for metrics. It really helped me hit the 4,000 watch hours you need on YouTube to hit partner, because I had over 100 students watching hour-and-a-half lectures 5 times a week for 6 weeks. So there was a lot of dedicated watch time that helped
me get over the hump. Why do I sound like this? It's because Zach redeemed the baby voice. We have fun little things you can redeem in the Twitch to modify my voice. Yeah. You can afford 15 hydrations, yes, but the hydrations have a timer on it to prevent me from dying of too much water. No. Yeah. Okay. Okay. With the magnetic field, as illustrated, if I equals 8. Find, I assume this is the force on each side. I think that's what they're saying, right? What is the moment, the magnetic moment? What is le bobinet? Oh, a rectangular coil. Oh, bobinet is coil. Oh, I'm learning French today. Bobinet is coil. The website, it's right there. Actualofficehours.com. There's a link. You know where it is. You guys got it. I know you guys are smart. Bobinet is coil. Cool. I'm glad I'm learning. And then coil est, what is le moment? The moment of the force exercise. So this is a torque, is what this is, I guess. I've probably dropped it. Yes. Oh, bobina is Portuguese. Oh, that's cool. Probably similar to Italian. All right. It has 22 turns. A rectangular coil. So wait, are these the coils? Or are the turns in this way? That's my question, actually. A rectangular coil has 22 turns. So I assume a turn is in this direction. What is capacitor? Yeah, tell me, please. This is 0.20. This is 0.45. And that's 38 degrees, and B equals that. Okay, so find the force. This comes from F is equal to I, and then it's L cross B. This is the way to figure out the force on a wire of length L with a current I. We usually say I points in the same direction as the L vector, and then B is the B field. So, one way to do this is just to recognize that this is equal to I. But we do care about the Okay, they want the components. Okay, in that case, we're going to keep everything in vector form. A lot of times you just ask what the magnitude of the force is. And in that case, you can just say this is I, L, B, where these are magnitudes. And then you just say sine theta. And then you're good. And then it's done. But since they want the individual components here, Josh, we have to literally calculate everything. Condensadora. Oh, that's cool. Or mechanica. What is the or it's mechanica or something. Portuguese is always weird because it's like slurring your words between Spanish and Italian. I always find it crazy. All right. B only points in the I direction. That's beautiful. Nice. We love that. So B is just going to equal to 0.3, and then you can say 0, 0. The 38 degrees is fun because then that lets me come up with coordinates for this, right? So for F1, let's figure out what L1 is, right? So L1 is the vector pointing in this direction, okay? So right away, I know what the z-axis is, right? So whenever I'm here or here or here or anywhere along segment 1, my z-coordinate is always going to be equal to 0.45. So here, we can just put that in right away. That one's easy. Okay. Now, figuring out the other parts. Okay, so we know this is theta. So this is kind of cool. So this is going to go from this amount in y to 0. So that's a negative change in y. And if I need the amount of change in y, that's going to be whatever this length is, and then sine of this. So here, let's call this like, what do you want to call this? I don't know. Let's call it like y1 or something. So y1 is equal to this, which is 0.20. So that's me 0.20 sine of theta. They put an ugly number for theta, 38 degrees, whatever. Okay, so that's going to be, and then it's, in terms of the vector L1, the current flows from here towards the origin. So the change in y for that vector is going to be negative. So that's going to be negative 0.20 sine of theta. So we're going to say negative 0.2. Oh, you got it all for me? Oh, is that the final answer, though? Wait. But we have components for it. There's components for it. Sine theta. Okay, cool. And then in terms of the x, so that's the amount here in x it travels, which is also going to be negative, right? Because it's going from having a positive x to having 0x. So this right here is going to be equal to 0.2 cosine theta, right? Let's call that like x1. Yeah. Okay, cool. And that's negative because it's also like going back. Okay. Nice. Okay, so that's L1. Here, we can get L2. So L2 literally just points straight down the z-axis. So that's going to have 0 change in x, 0 change in y. And then it's only going to have change in z, which is equal to negative 0.45. L3 is like this one, but opposite, but also the z is equal to 0. So that's going to be 0.2 cosine theta, comma 0.2 sine theta, and then that's going to be 0. And then L4 is going to have a positive change in z of 0.45. That's a lot of decimals. Leckle, dude, what? And this is also going to be 0.2 cosine theta. Well, actually, no. This one doesn't move in x and y, so this one is also 0, 0. Sorry. Yeah. Right, because this is only moving in the z direction. So there is no movement in x and y. Last calc exam. Dude, good luck, Edvin.
My man.
Is this something I might end up having to learn in AP Physics C? Yeah. Yeah, this would definitely come up in AP Physics C. I don't think they would require you to calculate all 4 of the forces, but they could definitely ask you to calculate one of them, for sure. This is a little overkill that they're making you calculate all 4, but they could definitely ask you to calculate one of them at least. Oh, also, yeah, sorry, I fucked up on this. L1, this should be 0. Sorry. Right, because the vector L describes the direction and magnitude that you go from your starting point to your final point. So when you're looking at sector 1 here, right, you're actually not moving at all in z, right? This is the same z as here. The z coordinate is 0.45, but the movement in z is 0. So let's see if this makes it, and we should see like some symmetry, right? 0, 0, right? Two of these legs have no change in z. 2 of these legs have no change in x and y because they're straight up and down. And then the ones that don't have changes in z also have changes in x and y. Yeah. Okay, cool. There's all the L's. So then I just have to cross this with b, which b is only in the x direction. So, this one's actually pretty easy here, because if you just have x cross z, there's kind of like some fun rules to this, so watch. So x cross y, or, okay, whatever. Let's say like I hat cross j hat is equal to k hat, and then it does like a, what's the name for this, where things like go around in a circle, like a merry-go-round? It's almost like a round robin. But, so then j hat cross k hat is equal to I hat. Is it rotate? And then K hat. It's like circular. It's like circularly periodic, I guess. Right? So like this cross this equals this, but this cross this equals this. And then, what is it? Like this cross this equals this. Yeah, I think there's like, it's like rotational symmetry or something. You know what I'm talking about? Yeah, there's a circular periodicity to it. So, I mean, the cool thing here is that if you do Z hat cross X hat, you're literally just going to get Y hat, because the Z hat and the X hat direction are perfectly 90 degrees with each other. So sine theta just gets you 1. So this is actually pretty fun. So here, L cross B is just going to equal to, in the Y direction, it's going to be 0, comma, and then this will be this times this. So, what's that? Negative 0.135? I think so. Comma 0. I can check that real quick. 0.45 times 0.135. Oh, I'm like absolutely wrong. No, sorry, times 0.3. What am I saying? Yeah, 0.135. Okay, cool. Mr. Waddle says, if you don't mind asking me, what subject is this? This is like AP Physics. I would say this is AP Physics C, E and M. It's in French, but we translate it a little bit. Evan says, I'm taking Physics 1 next semester. It's like calc-based physics engineering. Will it be hard? Yeah. I mean, this could definitely come up. So AP Physics 1 AP Physics 1 in high school is algebra-based physics. Physics 1, which, yes, is, at least at UCLA, the 1 series is the engineering, like, physics major physics. That is definitely a tougher one than, say, for instance, the 5 series, which is life science majors, which is algebra-based. Physics has a lot of formulas. It does. But they're all kind of related to each other, which is fun. Anyway, so this one's, like, not bad, right? And then this one is probably not bad at all, right? Yeah, this is the same thing, right? L cross B. It's just instead of a negative, we're going to get a positive. So 0, comma, 0.135, comma, 0. These ones kind of suck. Yeah. Because you have X cross Z and Y cross Z. What's up, Nero?
Oh, yeah.
Narosky, my math legend. Thank you. What's up, Narosky?
Good job.
Did anyone see Japan versus Brazil? Japan beating them 3-2 while down 0-2. Is that soccer? Soccer is my sport. Okay. I would ask Josh if he wants me to actually do this. Like, you can't do it. It just sucks. I'll show how to do one of them. Oh, actually, because the other one will be the same. No, it won't be. Well, yes, it will be the same. It'll just be negative. Right? Yeah, okay, here. Let's just do this one real quick. Because the other one is... L3 is just L1 times -1. Right? Fill out your survey. Yeah, post it. I have a... There's a link in the Discord for promo. It's called, like, Bulletin Board Self-Promo. Free Fire. If you want to just, like, put a server... Like, a link to whatever. As long as it's not like, you know, Bitcoin scams or something. I don't know. Bitcoin doing real bad these days, actually.
No.
My friends are just like, I'm poor. Like, so I don't invest in crypto. Okay. I, J, K. That's how we write this. This is like I hat, J hat, K hat. And then you have to write, so L, so this is me -0.2 cosine theta. We haven't gotten any quantum mechanic questions yet, Lecker. If we do, I'll let you know. They do show up sometimes. Maybe Clickbait has some quantum mechanics. He was asking some crazy stuff the other day. Why specifically Bitcoin? I don't know. When like my mom is talking about something, I'm just like, no. It's already lost the plot. It's already become like it's become its own little hype. It's hype at that point. Like, its value has lost its actual value. It's all just hype. It's like Tesla stock. Tesla stock is insanely overhyped and overpriced because all their stockholders are fucking cultists. Do you think Bitcoin will be at 100K by 2026? Yeah, it'll definitely go back for sure. Yeah. I mean, unless Trump keeps like doing shit. I don't know. He's all over the place. Okay. So, oh, I wrote this wrong. Sorry. Because this is... Oh, wait. No, I did this right. L cross B. Oh, wait a minute. Wait a minute. L was Z. Z cross X is Y. Okay, that's fine. All right. In this case, this is... so how to do a cross product is to set up a 3x3 matrix like this and then do a determinant. So this component is just 0, which is nice, right? So that's going to be equal to 0 in the I hat component. And then there's always a minus when we do the middle one. What's up, JC? Good to see you, dude. I'm going through my lecture right now, but I can put some quantum in the queue for a bit. Yeah, put it in for Lecker. Lecker would love to like chomp on it or something. Okay, wow, the Y component is also 0? Is that right? Yeah, this time 0, this time 0. Also 0. Yeah, isn't that you, Leckle? The Endo Forever, isn't your name Leckle? In my Discord? What's up, Anuvan? Wait, let me understand why this is. Okay, something in the X and Y coordinate with X and Y components crossed with something in the X component, yes, would only get me things well, because X cross X is 0, Y cross X is Z. Yeah, okay. Oh, and then that's why this one only gave me something in the Y component. Oh, very cool. What's up, Lester? Leckle. It's Leckle, dude. I'm saying Leckle. You're hungry? Go eat something, dude. We're doing cross products right now, which kind of take a little bit, honestly. Okay, let's do this one. Beautiful. Okay, so then it's just negative 0.06 sine theta. Okay. But then it's positive because we do this minus this. Okay, so this is 0.06 sine theta. Nice. Love it. Okay. Okay, so then this one is the negative of this. So this would be 0, 0, negative 0.06 sine theta. All right. And that's L cross B. So then you have to multiply by I. And I is 8 amps. Cool. Okay, so then here. I have a physics exam tomorrow. Momentum, conservation of energy. Any tips? Get really good at writing out what all the energies are. So there's like, right, there's rotational kinetic energy, there's spring potential energy, there's gravitational potential energy, there's regular kinetic energy. Friction is also kind of an energy. It just gets lost. Okay, so this one is equal to 0, 0, 0,06 sine theta. Yeah, the una bobine. Yeah, no, it is very cool. That's what we're doing. We're doing this one. It's in French. Coil is bobine. And also, it has 22 turns. Okay, so I have to do N-I-L-B. I have to move it around a little bit, right? This is N-I... Okay, here we go. Okay, so F1 is going to equal to N. That's 22 times the current, which is 8 amps, and then times L cross B. And we did all the L cross B's. These are all the L cross B's. Okay, so it's going to be just this. Dude, I got 6 months ago and the scammer threatened to leak my stuff. You told me about this, Free Fire. Yeah, don't worry. Those people don't actually have your stuff. They're just causing trouble. Okay. And then this is this. And I'm going to leave it as an exercise to whoever's question this is to just plug in the numbers. because the queue is getting kind of long. We're already at 9 questions. Okay, I need to hurry up. All right, I'm gonna do this real quick, and then if you're watching Josh, just plug in the numbers and tell me whether they're right or not. If they're not, come back and we can like kind of go over it. I'm going to, yeah, remember the windmill with the 23,000 blades? It was 23,000 discs. Nero says, I'm going to a math physics competition on Wednesday. I think the physics part is oscillations. Am I salvageable? Do you have any example questions from that? I mean, I can try to teach you in like, 20 minutes what you need to know about oscillations. It's all just sines and cosines. What else are you streaming? We stream on TikTok, we stream on YouTube, we stream on Discord, we stream on Twitch. I stream everywhere. So yeah, for those of you just joining us right now, the website is www.actualofficehours.com. That's how people are submitting screenshots for us to go through. So you can type your username, drop a screenshot in, hit live queue. These are everybody's questions so far. So if you click on stuff, we can see what everyone else is doing or wants to get help with. Yeah, that one. This seems like kind of interesting too. Wow, there's a lot of really fun questions we're gonna ask. Gold does don't send me feet pics, please. But right, and then also while you're there, you can click here to watch live on Twitch. Twitch is nice because it's horizontal. TikTok and YouTube are primarily vertical. That's just how the algorithms work. But if you want to see it on like your desktop, and there's a nice horizontal screen, just click here to watch us on Twitch. Also, if you want to figure out when we stream, click here for the streaming schedule. It shows when I stream, as well as all of our other awesome friends and partners who are streaming. So Zach's on there, Penn Center's on there. Joseph will be there at some point. And then you can click here to join our Discord, because every question we do, I will post the answers in the Discord. Can I do yours? I will get to yours. You have to wait though. There's a line. Okay, that's the forces where theta is equal to 38 degrees. Yeah, okay, cool. What is the magnetic moment? Is that like mu naught I or something? I forget what it is. And then what is the torque? So here's actually an interesting thing. Let's just talk real quick. I think some things cancel here on the torque. So for instance, if B is pointing this way, but L is pointing this way, and I only care about the perpendicular component to it, right? By IL cross B, L cross B, that means there's going to be an upwards force from here. Right, wait. IL cross B. No, B's the other direction, sorry. Ugh, I got this. And then I only care about... Oh, okay. No, force is down. Force is down. Sorry, this one has a downwards force. There's force pointing straight down, right? And I think we figured that out, right? What did we say on number 3, right? Yeah, that was straight down. That's negative Z. Oh, I'm trying to like move my finger for IL cross B. For this one, I points up, B points out of the page. So F points to the right. So this will have a force to the right. But then by the same token, this will have a force to the left. And then this will have a force up. So in terms of torque, do they say it rotates about the z-axis? Yeah, okay. So these forces will cancel each other out. So you don't have to worry about this, because this is up and this is down. But about this rotation point, however, you will have torque, because the force on this segment is at the rotation axis, so it does not contribute torque. This one does. And so this would end up being whatever the force of this one was times 0.2 times the distance. So I don't know about B because I forget the equation for magnetic moment, but I'll do it for C real quick. The torque which they write as a big capital T. I sometimes write as gamma. That's equal to R cross F. And in that case, you really only care about the perpendicular component to this force, right? So you only care about 0.2 cosine theta. So that's going to be 0.2 cosine theta times 22. Is it F3? No, it's F4. Sorry. Times 22 times 8. Wow, we got a raid. What's up, Obi? And then that's 0.35. 0.135. And then let's think. If the force is that way, the radius is that way. Wait, so R cross F. Torque is up. And then this would be in the positive z-hat direction. Okay, I hope that our relationship can recover. Okay, cool. All right. This was a good question. Thanks, Josh, for it. Appreciate it. It's cool. Joshua.
Well done.
All right. Ahoy, Obi. Nice. Shout out, Obi. And Simplex. What were you doing with Zach? I saw you were doing lesson planning with Zach. Are you guys running a course? I was at the gym tuning into Zach this morning. But then I think he was going to rage you as I was like getting in the sauna. But I heard something about lesson planning. All right, let's see. Let's mark that as done. Oh, we're doing some stuff for your Peter Lil Jadal series. Oh, okay. What's that about? Who's Peter? Saint Peter? Just got done cooking hibachi steak and noodles. Wow. That's nice. Bring some over, dude. I love hibachi. Hibachi's delicious. All right, let's see. Okay, was this one yours, Poison? I'll do one of yours. And then clickbait next up. Let me see. I'll do the one with maybe like group charge. This is actually a cool concept, current and how like the drift velocity for electrons is actually quite slow. You would think it's like the speed of light or something, right? But no, it's because electrons like bump into each other. Building thinking classrooms from British Columbia. Nice. How to get students to think and stay active in the classroom. That is such an important thing. I think the solution is like soundboards.
That's dope.
I love that Penn Center is now adopting my soundboards. And I saw, wait, Zach, you have some sound effects too in your stream now. Obi, when are you gonna get a soundboard? Do one per stream. Okay, I'm gonna do this one. I'm probably not gonna remember the next stream to go back and find your other one, but I will do this one at least for you. Yeah, so there's actually let me get a picture of this. Sorry. No chemistry, not yet, Kato. Maybe if I keep saying chemistry though, TikTok will start showing it to chemistry people. They listen to my voice. They know what I'm talking about right now. I have a bunch of sounds capture, gonna apply them in commands and bits. Nice. That's dope. Hell yeah. There's actually a lot of really cool pictures on this. Let's get a couple pictures because this is great for explaining like how electricity works. Ooh, I like this. Someone put something on Stack Exchange. How should I prepare for calc-based physics 1? Make sure you know your calc. Yeah. Make sure you know how to do at least like derivatives and integrals. Yeah, well, I'm just going to do part B. I'm going to do one of the parts. Part A looked boring. So I'm going to do part B. Okay, so here's kind of a cool thing. Because the question's asking how long it takes an electron to get from a car battery to a starter motor. So starter motor is the thing that like turns your car on. It turns the engine over, literally. It starts it. And then they talk about some currents and like how long the wire is. So, oh nice, your oh nice. Leckel's thesis was on electrons. So there's kind of like some misunderstood concepts about how like current works and how electricity is transmitted. So what happens is that when you want to move electricity from one side to the other, you need to create a potential difference. And that potential difference is what pulls electrons in certain directions. But here's the key thing. The individual electron at one location does not really provide the quote-unquote current from moving completely over to wherever it needs to be. What they actually do is they bump into each other. So, you're not actually getting like individual electrons moving. The reason why electricity can be transmitted very fast is that the electrons bumping into each other happens very quickly. And it's like a chain reaction that they all bump into each other and eventually like transmit the movement of electrons really quickly, really, really far away. So that's how electricity is. We're not literally taking an electron here and like pushing it all the way down. I mean, we are eventually, but that happens very slowly. So yeah, here's what they talk about. They say like here for electrons being pumped from a battery, they actually move with a very slow, what's called like drift velocity. So that's like how fast this individual electron eventually travels down the wire. Look at that. That's incredibly slow. That's like 2 times the 1, 2, 3, 4, 5. That's like 2 micrometers per second. 2 microns per second, dude. That's super slow. But what really accelerates the movement of electricity are these random thermal movements. It's called, yeah, this is the thermal velocity, which is 1.6 million meters per second. This is huge, right? Because these electrons are... so this is another cool thing in physics. Temperature is defined as basically how fast atoms are vibrating, or like, you know, with what energy they're vibrating. So just by the nature of there being like heat and temperature, these electrons are moving very quickly, but not very far. So they move very quickly over short distances in what's called like kind of like a random motion. Like, yeah, here's an example of it, right? You have electrons like going this way, or they're going this way, but so they don't travel completely straight. They actually move a lot like sideways and not completely in the direction they need to go. But that movement still creates enough bumping into each other such that the signal velocity, so the effect of things vibrating here being detected over here, is almost at the speed of light. So that's why electricity is transmitted very, very quickly. But the actual electrons that are like providing the current don't move very quickly. Fugacity. I don't know what fugacity is. What's up, Charlie?
Oh, yeah.
And then there's also another kind of misnomer with what we call current. So typically, if you set up a battery here with a positive and a negative terminal, right? So like this, we define current to move in this direction, right? That's what we say current is doing. In fact, though, we're not moving. This would imply, because current is equal to dq dt, this would imply that we're moving positive charges clockwise. But that actually is not what happens. So in electronics and electricity and all that fun stuff, the charge carriers are the electrons because they're smaller, so they can like they're not as bulky. They don't like bump into shit as much. And and they move a lot faster than the positive charge carriers, which would be the nucleus, the protons. So even though we define current, like, by convention to be going from positive to negative, what's actually happening is electrons are moving in the opposite direction. But it's effectively the same for all the electricity laws. Is Brownian motion... No, it is related for sure. Brownian motion is related. Yeah, definitely is. But you can think of... If you put an electric field by creating, again, a potential, right? Where you have positive potential here and negative potential here. That Brownian motion gets kind of, like, skewed. Where the electrons want to move more towards... Notice how here in this diagram, they don't draw any electrons going the opposite direction. Because they don't really want to go there. The electrons want to, in general, move towards the positive source. 90% yap, 10% math. We'll get to the math, dog. I was doing all this fucking math earlier. I wanted a break. Anyways, so when we talk about drift velocity is the physical movement of an electron in a wire. It's not the velocity at which electricity is transmitted. It's just the actual electron. Okay, so yeah, let's go to this question then. Move this up here. Just do it. So it says, assume the current flowing is 115 amps and the electrons travel through a copper wire with a cross-sectional area of 31. No thermodynamics. There's a little bit of thermodynamics to this, but we don't really... The temperature comes into effect when you talk about the resistivity of the wire. That is temperature dependent. Okay. What is the drift speed of the electron? So let's go get that. There's an equation for this. It's like J equals N phi something VD or something. Drift velocity equation. I've derived it before. I just don't want to derive it right now. Yeah, here we go. Yeah, there we go. This is physics. But you are right, username, that there's a lot of overlap with chemistry. Yeah, this is the way I write it, right? I is equal to this. I equals NAVQ. I remember this. And then I think V is drift velocity is how that works. I over NEA. Yeah, okay, cool. Yeah, that's the way I remember it. Yeah, dude, if we keep saying chemistry, then eventually TikTok will show this to chemistry people. They monitor our chat, dude. Okay. This is the equation. I remember this is what it was. So current, which in this case is 115 amps, is equal to N. That's the density of electrons, density of free electrons, and that varies on the material. So for copper, the density of, they say conduction electrons, so that's electrons that are free to move around and bump into shit. That's equal to 8.49 times 10 to the 28th. Yeah, just keep saying chemistry in the chat. Chemistry. Someone come ask chemistry questions. Is the acceleration of the drift velocities constant? Yes. Provided the potential is constant, which the potential with the resistance determines the current, right? So this. A is the cross-sectional area. So they kind of screwed with us here because they put it in millimeters squared. So you got to be careful here. That needs to be in meters squared. So you say how many meters squared? This is a little bit of chemistry. How many meters squared is equal to 31.2 millimeters squared? And then it's a little stoichiometry here, right? I say that 1,000 millimeters, or let's say 1 times 10 to the 3, is equal to 1 meter. But then you're not done here. You have to also multiply it again by another conversion factor of 1 times 10 to the 3 millimeters. Redox reactions. Yeah, right, yeah. Because then this gets you meters squared, and then this gets you the millimeters squared that cancel out with this. Okay, cool. So this is equal to 31.2 over 10 to the 6. So I can just say like times 10 to the minus 6, right? What's up, 1K? Okay, so then this is 31.2 times 10 to the minus 6. That's going to be the cross-sectional area. V is the velocity we're solving for. And then Q is equal to the charge. And the charge of the electron is 1.6 times 10 to the negative 19 coulombs. Cool. I think that's all we need, right? So let's pull out our calculator. Let's do it up. Okay, so 8. So, wait. 115 divided by 31.2 e to the minus 6 divided by 1.6 e to the negative 19. And then also divided by 8.49 times 10 to the 20. This is going to be really small. E to the 28. Cool. What does that get us? That gets us 2.71 times 10 to the minus 4. Okay, cool. So you get V is equal to 2.71 times 10 to the minus 4. Wow. That's very, very slow. Which is correct, yes. That is the correct answer. Ether says, what about the diffusion current as I feels due to the field? That could be a concentration gradient, or maybe I'm confused with... that is more like a semiconductor thing. We assume that the concentration here is constant. Semiconductors, right? You can have like NP, NP, like different doping stuff, like holes and whatever. And then, yeah, the reason they're called semiconductors, right, is because they're not fully conductors. They have like kind of a bipolar behavior to them. Okay, so this is the velocity, and then it says, given this density, what is how long does it take for an electron starting at the battery to reach them? So this is mechanics, right? So distance is equal to velocity times time. So if we just move distance divided by velocity, we'll get the time. And then the distance, how long is the wire? 85.5 centimeters. So we're going to say 0.855 over 2.71 times 10 to the minus 4. Or transistors. Sorry, not semiconductors. Sorry, what am I thinking about? Like doping? It's like doping stuff, right? Isn't that semiconductors? That's dope.
That's dope.
I dabble with electrical engineering. I kind of got partially a degree in it when I did my PhD in plasma physics, just because I had to build so many circuits and stuff. Okay, so that's 3154 seconds. So if we divide that by 3,600 seconds in an hour, that's 0.87 hours. Okay, but they probably want it in minutes, so times 60. All right, cool. 52.58 minutes. PhD title with plasma is also dope.
That's dope.
Yeah, it's on the website there. People always ask me for my thesis. You can go read my thesis. It's on that website, actualofficehours.com. Nice. Cool. So there you go. That's it. Poisoned. Hope you learned something. I learned something for sure. Good job, everybody.
Well done.
So it's pretty crazy, right? An electron takes almost an hour to travel down the cord to get from the battery to the starter motor. That's nuts. Right? That's slow. I didn't learn anything. Uh-oh.
Surprise, motherfucker.
I'm so sorry, Pen. Shout out to Pen. Good to see you. At Penn Center. Penn Center's another awesome friend of ours who does math, education, streaming stuff. He's a pretty cool guy. Doesn't afraid of anything. Does the electron actually travel? It does. No, it actually does travel, Ether. But I mean, if you're holding, I don't know, the ignition for 53 minutes, you're gonna have a bad fucking time, dude. You're gonna blow your starter. Don't do that. It takes around an hour for the particle to make it, not the energy. Exactly. The energy gets there quicker. The energy gets there at the speed of light, but the actual particle would not get there for 50 minutes. But nobody is going to do that. You should not hold your starter that long. Do not do that, please. Okay, let's go to the next question. Again, if you're just joining us and you found us, this is the website, actualofficehours.com. You can drag in a screenshot and it'll get added to our queue. And so let's see what's on the queue so far. Next one is clickbait. Wow, we're talking about inertia tensors? Oh, Jesus. Clickbait, you about to hurt me again. Unless you have a special starter, yeah. Unless you're, I don't know, like... They have some really cool starters for, like, airplanes in World War II. They would literally, like, fire shotgun shells. Like, it was a blank shell. Like, there's no bullets in it. But they would detonate the gunpowder, and that would provide the initial, like, oomph to, like, move the pistons. My Rocket League tag is in the Discord. Oh yeah, if you play Rocket League, yeah, we do have a tag for it, so other people can find other people who play it. Hurt people. Tractors. Do tractors do it as well? Yeah, there's another cool one. I think it's for the B-52 fast start or something. Yeah, the rapid start. Yeah, so these people use explosives. Oh, we got an advertisement. One second, we have advertisement. Let's stop. But yeah, they like detonate like bombs in the engines to start. Yeah, this is it. It's called a starter cartridge, and it's a small amount of gunpowder, and that force then allows them to like kickstart the turbines really quickly. Yeah, same as a fire starter made from compressed gas, right? Or ether or anything. Yeah. Yeah, they're pretty cool. I don't know. It's like some drill they do to see if how fast they can start a massive bomber. But like while charging a battery, if the electron moves, then the weight of the battery should change. I mean, yes, technically, right? I mean, batteries, I guess, do lose weight but dude, the mass of an electron is so small. What? It's like the smallest thing ever. Okay. Also depends on the battery. Correct. I don't know. Yeah, there's probably some... This is, again, chemistry. We're saying chemistry 4 times so that the algorithm starts sending us chemistry people. Yeah, there's different battery technology. Like lithium ion, right? Lithium phosphate, nickel metal hydride, NiCad. There's all sorts of stuff. Smallest thing ever is energy, and also the biggest thing sometimes. Okay, let's see. A rigid body can okay, so there's 3 masses, m at this, 2m at this, and 3m at this. Find the inertial tensor. Wow. The fuck's an inertial tensor? Let me go look this up. Ooh. Okay, here we go. The complete inertial tensor. It's a matrix. I do see that. Where does this come from, by the way? Clickbait does not like me very much. No, Clickbait, I love Clickbait. Clickbait has, he's going through a very intense physics class, which I enjoy. I enjoy just like getting hurt from these questions, but they're fun. Okay, I don't know where this comes from. If somebody wants to illuminate that, I'm totally cool with it. But also, like, I don't even fucking know what a tensor is. To me, it's a matrix, but is it like a transformation matrix? Yeah, I blame your professor. Dude, your professor is horrific sometimes, dude. Dude, some of the questions, like, Clickbait has had to go through, and dude, where's the one? Dude, this one was... Yeah, where is it? Yeah, they want you to, like, sharpen your teeth. No, but where is... It was in here. Where is it? Yeah, this question, dude, you had to do. You were asking, like, yo, is all of this right? I'm like, dude, what? This is so painful. I think you were deriving, deriving the Laplacian and spherical coordinates is what he had to do as professor. I did, like, we did part of it. We did, like, the very, very beginning of it. We did the first derivative, and then this is, like, you had to do the second derivative. Yeah. I think this is eventually what you came up with. Like, holy shit, dude, what? This is a lot, dude. Yeah, anyways. So, okay, inertial tensor. A tensor is something that transforms like a tensor. Man, dude, what? No. What? It's something that transforms like a tensor. This is classical mechanics jokes. It is. This is classical mechanics. Okay. Okay. So I have 3 different masses. So do I have to add the inertial tensors for all 3? Like for instance, so I1. Oh, well, here's a cool thing, right? I1 only has X components. So so I need something that only has X in it, which, so none of these diagonals work, right? Or these off diagonals, right? Because they all have Y's and Z's. Oh, so it's only going to be these. Oh, very cool. Love that. Okay. So this is just going to be, let's see, 0, 0, 0, 0, MA squared, MA squared, right? And then I2 is 2M, but only at Y and Z. Okay, so, I mean, right away, I know this one has to be something. Actually, let's pull the M's out. It is like the moment of inertia. You are right, Ether. I'm pretty sure it is like the moment of inertia, but it's generalized for, like, all the coordinates or something. It's like crazy 3D. Like, you know how moment of inertia is usually based on one axis, right? Here we go. Moment of inertia table. This is usually what comes up, right? If you've ever taken physics, this is usually the graph you get. This is, I think, the inertial tensor, but reduced down to one axis. So what the inertial tensor does is it gives you all the possible moments of inertia, and then you just have to, like, collapse it based on, like, what axis, like, what thing you're trying to rotate about. I think that's how this works. Someone correct me if I'm wrong, but I'm pretty sure. Okay, so let's pull the M out. All right, let me look at this one. So in this case, Y and Z are still good. Okay, so this is going to be 2A squared, right? Because you have A squared from the Y and A squared from the Z. So this is 2A squared. Anything with X is 0. So that's 0, that's 0. That's 0. That's 0. But these two are okay. So we get negative A squared. Or negative... Oh, here. Let's pull the 2 out. Actually, sorry. Let me just pull the 2 out because this is going to get messy. Negative A squared. Negative A squared. And then this is just going to be A squared. And then A squared. Or no, 2A squared. Sorry, this was all... No. This is just A squared. This is 2A squared. This is 2M. I think that's how that works, yeah? Cool. And then I3 is similar, except there's a 3M, and then the Z component is negative. So let's see. That's not going to change anything here because these are squareds, right? This is still going to be 2A squared, A squared, A squared, but these are going to switch sign. Okay, so this is going to be A squared, and then this is 0, 0, 0, 0. Nice. Okay, cool. And then, do I have to add them all up? Nice, Lyco, you already got it? Okay, let's see. So then, I total is equal to I1 plus I2 plus I3. So let's see. I got a 2MA. So this is 6MA squared plus 6MA squared. So I think that's... No, 4MA squared plus 6MA squared. Okay, let's do it unit by unit. So nice thing is all of these are all going to be 0. Right? That's beautiful. Love that. So I can go ahead and just write zeros here. That's okay. And then if we look at just the top left point, that's 4MA squared plus 6MA squared. That's going to be 10MA squared. Now these are going to add... I have an MA squared plus a 2MA squared plus a 3MA squared. So that's a 6MA squared. And then this is also 6MA squared on this diagonal. And then here we have zeros. So -2 plus 3 is just 1. Oh, so this is just ma squared. Ma squared. Nice. Okay, we did part 1. Okay, cool. All right. Find the principal moments and a set of orthogonal principal axes. Oh dear. I think I have to diagonalize this somehow, right? Diagonalizing a 3x3. Well, this is actually kind of cool, right? Because I mean, you already have. This is kind of diagonal. What do they call this? Where like this is and this is, but like they're all on the diagonal. Someone said block diagonal. Okay, cool. That's what I was looking for. Okay. So I think I can leave this, and I think I can tackle this individually to try to diagonalize this. Right? Because this is already like an eigenvalue. So this is a determinant of this thing minus I lambda, right? And this has to be equal to 0. So you get 6 ma squared minus lambda. Ma squared. 6 ma squared minus lambda. Nice. Okay. And then the determinant of that needs to be equal to 0. So these are going to square, and then it's subtracted from that. Okay. This is like almost a difference of squares, no, right? I have 6 ma squared minus lambda squared minus ma squared is equal to 0. Look at this. This is the same thing you learned in pre-calc. A squared minus b squared, right? That's equal to a plus b, a minus b. That's beautiful. So I can just rewrite this as 6 ma squared minus lambda minus ma squared. And then 6 ma squared minus lambda plus ma squared. What is the difference of squares? That's this. What's up, Jaden? Yeah, this is... You learn this in pre-calc. This is a very important thing. Dude, look, this is coming up in, advanced physics. This is why I say everything builds on itself. You can't forget this shit. You have to use it all the time. Okay. So, this gets me 5 ma squared minus lambda. This gets me 7 ma squared minus lambda equal to 0. So in that case, lambda is equal to 5 ma squared, or lambda is equal to 7 ma squared. Okay, so now we have our eigenvalues, right? That's pretty cool. Okay, so let's, I think I can pull like an ma squared out of this whole thing. Yeah, let's look at this. This is cool. This is linear algebra, right? Eigenvalues, eigenvectors. Okay, so now... What will physics mainly talk about for calc-based? So you're going to do derivatives for sure. To be able to find, like... So the derivative of position is velocity, derivative of velocity is acceleration. That happens a lot. And then you're also going to do integration for doing... for instance, work is like integral of f.dr. That one comes up a lot. And then if you get into E&M, a lot of like potential stuff is all integrals, like Biot-Savart is all integrals. Sadly, yes, it's linear. Yeah. What's linear? Are you saying this is linear? Are you saying this is like this is a boring one to do? Or are you saying like calculus is linear? Okay, so this is ma squared. And then look, if we plug that in, that's 6 ma squared minus 5 ma squared. That's 1 ma squared. So 1, 1, 1, 1. Oh, this is boring, dude. What? Or, right, and then this is times some, like, what is it? x1, x2, basically. And then you have, ma squared, so minus 7, that gets you -1, 1, 1, -1. x1, x2. Did someone say linear algebra? What's up, Femistral? I did. Yeah, we're doing linear algebra, Pen. Dude, this is an inertial tensor, which I'm then diagonalizing, or I'm finding the eigenvalues of. So we figured out that this is block diagonal, because this block and this block make a nice little diagonal. So I can just solve for the eigenvalues of this one, because the eigenvalue of this one is 10 ma squared. And then to figure out these vectors, right? This tells me what, like x1 plus x2 has to equal 0, but right, okay, that's not really new information, right? And then this is x2 minus x1 equals 0, and also x1 minus x2 equals 0. Great. So here they're opposites. So you could say vector 1 is just equal to, what is that, 1 and -1? I guess if I wanted to normalize it, I could do the 1 over the square root of 2. And then this one is just 1 and 1, right? Okay, cool. Oh, but these are, I teach physics. These are this branch. Okay, so actually, here we go. So the full eigenvectors are, okay, very cool. So you have lambda 0, which is the first one we found, which I guess is equal to I1. That's just equal to 10 ma squared. And that's just a single thing in the x-axis. So that's a long x. Along, you can say 1, 0, 0, right? Lambda 1, that's equal to I2. That was equal to 5 ma squared. And that was along 0, 1, -1. So that's like the diagonal YZ axis. Something diagonal in YZ. And then lambda 2 is equal to I3, which is equal to 7 ma squared. And that was along 0, 1, 1. Wow. Okay, cool. I think we did it. Nice. That wasn't so bad. Good question there.
That's dope.
Thank you, Clickbait. That's actually kind of fun. I got to remember about inertial tensors, and then how to diagonalize them, and then we learned about block diagonalized, and then I learned about how to figure out eigenvalues and eigenvectors again. There was a lot of stuff going on. Sick! Okay, let's mark that one as done for Clickbait. Suros, you just came back from Home Depot? Sick. I love Home Depot. Home Depot has so many nice memories, because me and my dad was always just trying to build shit. And, like, involve me with building shit. Which I'm glad he did, because I'm a very hands-on person now. Like, anytime my friends need to, like, build a shelf or something, they just, like, you know, call me. I do need to hydrate, thank you. But yeah, I love the smell of, like, lumber. I built speakers with my dad in high school. When I was first getting into DJing, I didn't really have the money to buy like a PA system, but you could buy these plans online for like how to build these boxes, and then you could buy the drivers and then the electronics and the hookups, and then we did them all, and then I built my first set of DJ speakers, which I still own. I still have them. Yeah, actually I have all those speakers. I still do. I don't use them as often, but I do still have them. Okay, let's see what the next question is. That was physics, IKEA. Let's see. The vertical circle. Is this a GCSE question? The onlinephysicstutor.com. Okay, cool. What are we up to, Briggity? We did do, this was some linear algebra. It's technically physics, but it was like tensors, called inertial tensors. And we definitely did have to do a little bit of linear algebra. I think what we're doing now, we have been getting a lot of physics today, which I'm happy about. My PhD's in physics. Yes. Also, let me give a shout. I didn't give a shout out to Zach because Zach, you came when no one was here. So, give a shout out to Zach. Zach's another awesome, great math science teacher, educator, influencer. We can call you an influencer, Zach, right now. Yeah, can we call you an influencer? You definitely influence people. He also does a lot of fun streams where it's not just math. So my streams are mainly like I just help people with their math and science homework. But Zach also does like coding streams, and then he has a podcast with Penn Center. When's your next podcast, guys? They have fun little discussions, and then they also Penn, you have like Beyond, was it Beyond the Blackboard? That's the podcast. And then Zach also does like math on a topic, which I think for the last 2 weeks was Laplace transforms. So if you wanted to learn about Laplace transforms, Zach did like some really cool streams on them. Next Monday, November 24th. Nice. Is it on the calendar? Yeah, to those that are watching, if you want to figure out whenever the rest of the awesome streamers that I work with are streaming. Yes, here we go. Special event. Beyond the Blackboard.
Good job.
Yes, that's going to be on Monday. Nice. Great. This will be fun. I will be at the gym, but I'll tune in. Do you guys have have you guys picked the topic for it yet? Is there a special topic? I know, last time, I think it was like education. Or is that maybe just in general? Oh, one more week of Laplace transforms. Oh, nice. Yeah. Okay, cool. So yeah, if you want to go learn more about Laplace transforms, Zach is doing another math education stream. So these is where like he does help out with math questions, but the beginning of it is at least he goes over kind of some cool topics and concepts in math, and he kind of teaches it from not scratch, but from more of an intuitive point of view, which is fun. Yeah. I'm hitting the wrong buttons. Okay, there we go. All right. Let's see. A small ball of mass m hangs from a light, inextensible string attached to a fixed horizontal post of radius r, as shown. The ball is hit horizontally with a large bat. Ooh. So that the ball wraps the string around the post. Show that the ball's speed at the top of its first swing must be at least this, so that the string remains taut. That was Zach and me getting ready for our next podcast. Those were not incorrect button presses. Yes, it was all part of the plan. Okay. To remain taut though, that's interesting. Okay. So the ball is here. It has some
mass. Yes, more baby voice, Penn Center. More baby voice physics. This has to swing up here also, I guess, a distance. Here, let me draw this out. Michael's like, oh god, no. It's all part of the fun.
Okay. Because I just don't want to redraw this diagram. No! This is before. And then we're going to have an after situation. Where this is no longer here. But it is located another distance. And this is going to go into centripetal acceleration, which is cool. Very cool concept. This is also going to be R2. Good question, Fembox. Is the ball at the top when the string has wrapped around exactly a quarter of it? Yeah, I agree. Oh, so yeah. So actually, Fem is even more right. Sorry, so it's actually this distance, right? Because the rope will have done this. If it's pointing straight up... Well, actually, that's a good question, actually. At the top of its first swing. Yeah, that must be the top, right? I use Group World. Is what I use. I use Group World. Microsoft Whiteboard's pretty chill, too. Maybe the string is connect... Well, one sec. What's happening here? Because, bro, I hope to God there isn't, like, some... Like, I gotta figure out, like, the component of the centripetal acceleration, which is, like, not tangential or something. I don't think so. This is probably supposed to... We're gonna, like, assume that, you know, R1 is small compared to R2. And also, Fem, the fact that I see R2 here, like, this is, like, GH. Oh, but look at this. This is GH minus... This looks like some sort of circumference, right? Really cool. But it's pi r divided by 2. So yes, that is a quarter, right? That's a quarter. Right, because a full would be 2 pi r. So I could definitely do something in accelerated motion. Yeah, for sure. Okay. Alright, so when the thing is here, okay, versus when the thing is here, and we need the rope to be tight. In order for the rope to be tight, you need the tension to be like greater than or equal to 0, right? Which, if we draw like the force diagram here, you're gonna have do we know what the mass of it? Yeah, cool. So we have mg pointing down, right? And then we're gonna assume that the tension is equal to 0, because that's the breaking point for it no longer being tight, right? The second ropes like lose their tautness is when tension is equal to 0. So 180 or pi is involved. No, it is cool. Yeah. Well, so the reason JHNet that I started seeing things is this looks like to me the square root of GH. This is usually a thing that comes up a lot in physics for various like maximum height or maximum velocity or whatever. It's always like square root of G over H or something. It's just something we notice as a pattern. But I notice here that the height is R2 minus pi R1 over 2, which makes me think that they're referring to like this like new height, right? From the rotation point. But that the new length of this rope after it's wrapped around a quarter of the thing as it's swinging up is going to be its original length R2 minus a quarter sorry. My chest is cramping. Minus a quarter of the circumference. Oh. Ugh, water. Stop it. Chest. I did a lot of chest press today and my chest is cramping. Oh, okay, there we go. Ugh. Yes, I do need more water. One sec. Yeah, it is wrapping around a quarter. That's why the length of the thing is minus a quarter of its circumference. You know what I really should have done is I should have eaten some magnesium. RK says, how do you graph in vertex form from standard form? You do completing the square, RK. Completing the square is the way to do it. How do you submit a question? Go to that website, www.actualofficehours.com. That's the best way to see. All right. need to be able to write today, though. Okay. I think if I keep my chest up, there we go. That feels better. Oh, all right. Okay. If tension is 0, mg is the only force down, then the sum of the forces in the y direction has to be equal to the mass times the acceleration. And if this thing is moving centripetally, right, in a circular motion, A is equal to v squared over r. So in this case, we say that mg, because that's the only force there, must be equal to mv squared over r. M's are going to cancel, love. So then v is equal to the square root of gr, where r is the distance from the center of the rotation to where the thing is, okay? But if this has wrapped around this amount of distance, right, which is a quarter of the circumference, right? So this is 1/4 of the circumference. The clock stopped. That's weird. It'll refresh. Just give it it refreshes. Like, TikTok is weird with refreshing HTML sources, but it'll do it. Yeah, it's fine on Twitch and YouTube, but TikTok, it'll do it every minute. That's why I have to force the refresh on it. Okay, circumference is 2 pi r. So it's equal to pi r over 2. Nice, okay. So nu r is equal to r2 minus pi over 2 r1. The instantaneous center of the rotating ball is the point of tangency of the spring and the post. Yes, I agree. So this is how you now get v is equal to the square root of g, and then this is going to be r2 minus pi over 2 r1. And I think that's what we had. Yeah. r2 minus pi over 2 r1. Nice.
Good job.
For the speed of the ball in A, show that the initial speed must be at least this. Okay. That has to do with conservation of energy, right? So if we call this height equal to 0, right? So then energy total is going to equal to mg0. That goes away. Plus 1/2 m v naught squared. Cool. Energy total here, that's equal to 1/2 m this squared, right? So this thing squared. And then plus the new height. But h new, so the new height is equal to r2 to get to at least there, right? That's equal to r2. And then plus r1, right? Because r1 will get me to this point. Nice. And then plus the plus r2 minus pi over 2 r1. Nice. I think so. Okay, nice. Good. I'm glad you're here, IKEA.
Yeah.
Isn't it nicer on Twitch? It looks nicer, right? It's wider. Okay. Okay, so this is equal to 1/2 m. Yeah, it's wider and less lag. Yeah. Again, the reason why I have to stream vertical and why I do stream on TikTok and YouTube is the discovery there is a lot better. Twitch doesn't do the best job at like promoting our stream to new viewers TikTok and YouTube do. They're very good at that. But in order to get on the algorithms for YouTube and TikTok, you have to be vertical. Because that's where they really pump it. Okay. So see, this is 2R2. So that's 2R2. Plus, well, that's 1 minus pi over 2 R1. Welcome. Do you have quantum mechanic questions? Lecco really wants to do a quantum mechanic question. Okay, cool thing. Look, dude, the M's go away. M goes away, M goes away, M goes away. I almost wanted the 1/2 to go away. It almost did. Whatever. Let's get rid of it, and let's just put a 2 here. And then I wanted the G to go away, but it doesn't go away either. Fuck. All right, so let's see what we got. So then we have... What's up, Machka? V naught squared is equal to... so this is R2 plus 4R2 plus 1 minus pi over 2 R1 plus or minus pi over 2 R1. Right? I got an R2. I got 4 R2s. I have a minus pi over 2 R1. Then I have a 2 times that R1. So I stream both, GUI, actually. I do. So, YouTube, YouTube is working towards doing what's called like dual format streaming, which means that if you stream in one format, it automatically puts it in the other one. But I haven't gotten accepted to it yet for YouTube. I do have it for Twitch. So in Twitch, there is a vertical now. Because we got accepted to that beta, because I went to TwitchCon. TwitchCon is great, by the way. Cool. Look, 5R2. Love that. And then this is minus pi R1 minus pi over 2 R1. So that's minus 3/2 pi R1. And then plus 2, I think. All times G. Yep. I almost forgot the G. Okay, so then that's equal to that G square rooted. Is that V naught? Yeah, do you see that, IKEA? You can click on it and it'll actually show you the vertical also in fuck, what is it? Wait, where the fuck did this 2? I'm missing a 2 though now. No plus 2. 5 is R2. Well, there is another 2 there though. Oh, you know where I'm missing this? This is also 2R1. I forgot. This also goes on this. Yes. Okay, so yes. So this does equal this thing. It's the same thing. TikTok was so narrow. Yeah. Yeah. Nice. Okay, cool. That's the same answer. We did it. Congrats. Where did the G go? Where did the G go? We put the G back.
Well done.
Nice. That's a fun question. Okay. Whose was that? My R1 might be off? I don't think it is. No, we're good. Not so after hours. Okay. Boom, 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 boom. Do I know how to do Diffie Q? I do. Hey, Gold. Do you know if you can answer some finite sets problems with modulo? I got a no homework today in linear algebra. I mean, you can submit it to the queue. I'll see if I get to it. I only got like an hour 20 left, but you know what happens, right? If I don't get to it, it gets put in our Discord anyways. I tag the math gods, and then if they feel up to the challenge, the math gods are merciful and they'll come through and help you. I would also recommend, Becky, do you follow Zach, either to iPie? Yeah, there's the queue. You don't actually. Oh, well, go follow Zach. Yeah, Zach is very smart. Zach is smarter than me. And also is Obi. Yes. Damn, the queue is long. Yeah. Well, that's what happens. We're 2 hours in already. But again, not to worry. If you're watching this and we don't get to your question, they always get added into our Discord, which can help you out because, for instance, this happened to Becky yesterday. Becky had a really tricky question. Where was your question? Here it was. This was your question, Becky. So anything we don't answer gets put into our homework help theorem or homework help forum. Sorry, is what I meant to say. And sometimes other people, if I tag the math gods, that means the people who are really good at math in my Discord may like come by and bless it with a solution or like their thoughts on it. So I hope this helped Becky. Waldo's a great guy. That's Mathematic Fanatic, I think, on TikTok. Yeah. But also, please submit something to the queue, even if the queue is long, because it'll probably get answered by either me at the end of the stream or by one of my awesome actual educator friends after the stream. Or if it doesn't get answered in 2 days, we have a Microsoft subscription that eventually will go through and solve it for us, because I vibe coded a Discord bot that will run it through the most expensive version of ChatGPT. Let me see what our balance is, actually. Probably check it. What's it called? Like Microsoft balance. Probably. Here, yeah, we can check our balance. See how much money we have left on Azure. Nice. Yeah, no, we still got $1,200 left. So I can still run a lot more ChatGPT requests through it. Yes, our case. How do I submit a question? So yeah, the website there's actualofficehours.com. Okay, maybe tomorrow. Cool. We will be streaming tomorrow as well. Okay. Free Fire. What do you got for me here? Looks like something with... It's better seeing you solve it in real time. You like to watch me struggle, Becky? Becky's like, watch me struggle. Yes, ChatGPT gets questions wrong all the time. And it's actually really cool to see when it gets it wrong, because it kind of reaffirms your confidence and like you know what you're talking about. I love catching ChatGPT slipping. It's great. I think that, and this is why in the Discord I put at the bottom, I say ChatGPT sometimes gets things wrong. Like, use this only as a reference. You should use it, and you should double check the steps while it's doing things to make sure it's doing it correctly, because it will fuck up for sure. But there's also a skill in being able to like proofread someone else's work and figure out where they messed up. So I think it's very useful. Okay. All right, two coaxial conducting cylinders of same length L with radius square root of 2r and 2r are kept as shown. The charge in the inner conductor is Q. The outer conductor is grounded. Okay, cool. So that means the potential is equal to 0. The annular region between the cylinders is filled with a material of dielectric constant K equals 5. Consider an imaginary plane of the same length L at a distance... Oh, dude, what's going on here? This plane is parallel to the axis of the cylinders. The cross-sectional view of this arrangement is shown in figure 2. Okay, cool. Oh, will it? JHNat? That's funny. At least you do Albert's daily 4x4 inverse before you end the stream. Seeing you struggle with math problems is actually fun to watch your thinking. Yeah, no, that's cool.
Oh, yeah.
I like to say, you know, you can always teach people the right answer, but it's better to teach people the process of like how you attack things. Long question. I don't know if this is... I mean, it's multiple choice. We should be able to just solve this easily. What am I solving for, by the way? Okay, the flux of the electric field through the plane. Ah. Fascinating. Through the plane. Well, okay. Here's the cool thing. If this is grounded, and I assume it's a conductor, right? It's conducting, right? The charge on the inner cylinder is Q, and the outer cylinder... Okay, so... This has a potential equal to 0. This definitely does have, like, some sort of potential. And then, okay, if this is grounded, this means that Q is equal to 0. It is a cylindrical capacitor. And then they want the electric flux. So all I really care about is the electric field produced through here. Right? Oh, and I think I get it. I get it now. Yeah, and then this is the dielectric. Okay. And the dielectric is equal to 5. So, let me see. Cylinders, capacitance. I think it's kind of what I want. What's up, Alistair? You're not late. You're still here, dude. Right? No, actually, it's my electric field. Electric field. Capacitor. Cylinders. The potential between the cylinders is V is equal to... Yep, here we go. This is the whole thing. I'm not gonna, like, rederive this. I think you can use Gauss's law to do this if you really want to. But this is literally the same situation, right? Right? This is at a potential V. This is at a potential V naught. Then, use Laplace's equations. Nope. Nope, that shit ain't happening. Dun, dun, dun. Okay. So then, this is the equation. I remember this. It's something with like LNs. And then we're going to have to do something with the dielectric. Oh, did it send you a warning in what? Were you posting a link too early because you just joined? Or, sometimes it gets mad at like swearing or something. Oh, don't worry about it? Okay, cool. Oh, yeah, okay, yeah, posting... Oh, because you tried to post a GIF, probably. Yeah, that's okay. If you chat a little bit in the Discord, it'll remove that. That's always a temporary protection, because new people joining our Discord sometimes are bots, and I don't want them to just, like, spamming links. It's a police state over there. No, we try not to. We try not to be like that. Okay, I need something with the dielectric, though, right? That's the next thing I need. I kid. What is it? The dielectric constant E. Is it divide by K or what is it? There you go. This is what I want. Thank you. Okay, VF is equal to V naught over K. Yes, that's what it is. Okay. So, yeah. So V is equal to V naught over K. Finding electric flux is 0. Then if Q equals 0, well, Q equals 0 here, but there is definitely Q here, right? So, so you do still definitely have a, yeah, it's not just KQ or R squared. This is a kind of this is a complicated geometry you have to do to figure out the potential of like two cylindrically symmetric conductors with charges. This is what you eventually get. And that's the potential in between A and B. And so here's what I kind of want to say. I don't think there's any E field here. Right? Because they said this is also like conducting, right? So I don't think there's any... And they said they're conducting cylinders. And because they're conductors, right, that means the charge only lives on the outside. But that means the E field on the inside is 0. So none of this actually contributes at all, right? But there is electric field here, which is related to this equation, right? And that electric field is radial. So then, I guess what's going to be interesting here is to try to define, because there's, all right, if that's 0, and then always from positive to negative, right? So there's electric field like this. And the flux, right, is the amount of this that's perpendicular to this. Oh, wow. And then I need to add it along this line. But then the value of the electric field... Well, actually, no. The electric field is constant in between these two things. Okay, cool. I think I know where to do this. Okay, wait. The electric field between the inner conductor and the outer conductor, right? That's equal to the potential difference between this and this. But the potential at the outside is 0. Is this a JEE advanced question? It probably is. Fucking hate JEE, dude. But whatever. What's up, Indian Super X? Alright, so I think... So electric field is equal to delta V over D. Which in this case is going to be equal to the potential on the positive end minus on the negative end. But on the negative end, the potential is 0. Did somebody say chemistry? Yeah, keep saying chemistry. So that's the potential here. Oh, we actually don't know what the potential there is. Oh, sorry. Oh, fuck. Oh, fuck. Wait. I just need to know the capacitance then. Oh, yeah. Wait. Q equals VC, right? So V is equal to Q over C. I know the charge is Q. I need the capacitance between two of these. Yeah, no, rho in this case is R. This is R. I don't think this is actually really necessary. Well, actually, no, yeah, it shouldn't be. Electric field should be constant. It should be constant within the dielectric. Yeah, then what's the capacitance of 2? Capacitance for 2 conducting cylinders. I know there's an equation somewhere. There it is. Yep, that's what I want. Yeah, kind of like that GUI. Yeah, so GUI. This is grounded, so the potential here is 0, and there's no charge here. This does have a charge Q. So this is capacitance. So C is equal to 2 pi epsilon naught. And then if they said K is equal to 5, K I think is equal to epsilon R over epsilon naught. Is that right? Or is it epsilon naught over R? Sorry, what is K? Ah, fuck. Where is it? I don't want the chi stuff. Okay, there we go. Oh, K is equal to epsilon R. Okay, got it. Got it. It's relative permittivity. Okay. Okay. So this is times 5. And then the length is equal to L. You think it is? All right, well, let's see. And then it's the ln of R2, which is 2R, over... You can definitely give me screenshots. Yeah. And this is square root of 2R. So these cancel, right? So, what is this goofy-ass music? It's kind of fun. Alright, so... And then V is equal to Q over that. And then we do that divided by the distance. Yeah, this is definitely a JEE question, dude. What? No. I fucking hate JEE, dude. Yes, I can definitely show law sines and cosines. JE is awesome. Oh man, I'm looking. I found the solutions for it. Dude, this thing sucks. Nope. All right, I'm skipping on this question. Nope.
Obviously,
Don't do this question.
You do whatever you like.
Don't do JEE questions. They hurt me. They hurt me so much. Also, I have a lot of questions in the queue. But yeah, this one is a pain. Also, like, I can't really do it during a live stream. Dude, it would take me like 40 minutes to do this one. But not to worry. I will still post it in my Discord if someone wants to go over it. We should have an all JEE stream? Dude, no.
Surprise, motherfucker. Surprise, motherfucker. Not good.
No, dude. Dude, JEE is like... It's just not fun. Yeah, I forgot that, like, anyone with, like, an Indian-sounded name who's submitting me physics questions is probably submitting me JEE, which I just don't like doing it. All of my other streamer friends here have similar opinions on just JEE being, like, absolute trash. For education. It's great for selecting, like, what 0.1% of the population is going to escape poverty, and I get that purpose of it. But for, like, getting people involved in math or science, it's just brutal. It's just scary. It's monotonous. It's time consuming. It's just like, it's not fun. Yeah. They do solve it in an exam. Yeah, they definitely do. And again, they have to because there's a billion people competing. But for the average person who wants to get involved in physics, seeing JEE is just like, it's overwhelming. It's too much. To me, it beats the fun out of physics. That's what it does. It's just like, hey, do you like physics? Well, now you don't. And I'm sure the kids do solve it. It's great for them, you know. I get it. It's a metric. They just need it because it is such a ticket out of poverty. Yeah, time consuming. Yeah, exactly. Okay. All right, in an ideal flow, a liquid of density 885, whatever, okay, from a horizontal tube of radius 2 centimeters into a second horizontal tube a radius 1 at the same elevation, the pressure difference between is... Okay. Wait. The pressure differs by delta P. Oh, okay. Find the volume flow rate as a function of delta P. Is this the Bernoulli equation? I think it's Bernoulli equation. So JC says, yes, the actual exam is monotonous, though, because I believe you're expected to just memorize a million results like those and just plug stuff in. Yeah. Yeah, that's what I'm talking about. It's just fucking brutal. It doesn't really teach you how to think. It teaches you how to hate. Just teaches you how to hate physics. Okay, this is Bernoulli's equation. Yeah, exactly, JC. I agree. Yeah, I should put a ban on JEE questions. I usually do. Whenever I see someone and they say, do you do JEE? I'm like, no, I don't. Exactly. That's how the education system works to sift people out. Yeah, that's what they have to do. There's too many people that are trying to escape being in really shitty situations. And so the only way they can do that is to make an exam that is so brutal that it really selects for like who is willing to memorize all of the solutions to all these like ridiculous physics questions. Yeah. Okay, and this is plus 1/2 rho v2 squared plus rho gh2. All right, so what I did was I just moved p2 over here, so it's p2 minus p1, which is the same thing as delta p. Also, we know everything's at the same height, so these go away. And then the volume flow rate. Ooh, okay. Now, volume flow rate, I think is... Yeah. That's going to be area times velocity. Right? Yes? And so, I think there's another equation here that says, like, A1V1 equals A2V2. Right? This is conservation of... Yeah. Okay. I think I get this. Yeah, okay. But then how's that going to relate with here? Okay, so... I guess I can move this over, right? No, I actually want to do it the other way. Let's move that over, okay. So 1/2 rho v2 squared minus v1 squared is equal to negative delta p, right? And then I think volume flow rate is A1 V1. So how do I pick out A1 V1 from here? Oh, I guess. I think I see. I think I see what happens here. Wait. So wait, v2 squared is equal to v1 squared. Sorry, is equal to 2 over rho v1 squared minus 2 over. Or here, let's just move this all over. Sorry, is equal to 2 over rho v1 squared minus delta p, right? And then I just need to figure out what A2 V2 is. So then A2 V2 is equal to what is that? 1 centimeter. Okay, so pi 0.01 squared V2. But then V2 is equal to all this. So that's equal to 2 over rho V1 squared minus delta P to the 1/2. But then here's the interesting thing. I don't have any velocities. Find the volume flow. I mean, this is a function of delta P, but it's also a function of V1 squared. Which V1 squared is a function of A2 V2, right? So V1 squared is equal to A2 V2 over A1 squared. But man, how am I going to get that out? Okay, so maybe we set this equal to so let's set this equal to z, because this is the thing I'm solving for. So it's equal to z squared over A1 squared. Okay, so then let's square this. Square both sides. Z squared is equal to pi times 0.01 squared. And then this is 2 over rho. And then V1 squared is equal to z squared over A1 squared. Minus... No, I agree. And that comes from here, Fembox. A1 V1 equals A2 V2. So, yes, if the radius is dropping by 1/2, then r squared drops by 1/4. So then the velocity should go up by 4. But the issue is that I don't have any initial velocity, right? So this is not z1. So z squared. Thank you. Thank you. Squared. Or here, let me just, sorry, yeah. Thank you so much, jokes. Squared. Let's do that. 2 over rho, z over a1's, so it's z squared over a1 squared minus rho. Okay. And then we're solving for z here. This is just fucking ugly, dude. Okay. Let me call this A2 squared. Let's just try to keep things organized. A2 squared over A1 squared, 2 over rho, z squared, minus A2 squared delta P. So then move that over, divide. I get z squared is equal to negative A2 squared delta P all over 1 minus A2 squared over A1 squared 2 over rho. Right? Oh, and then we already know what A2 minus A1 is. A2 over A1 is a 1/4. So then it's a 16th. So I don't know. Okay. So Z oh man, this is just nightmarish. Why do I get back-to-back nightmare questions? Y'all are hurting me. Also, it's negative. I don't like that. I mean, I guess we hope this is greater than 1. But I don't think it is. We hope this is less than 1. Less than 0. But it's not. All right. Thank you. There are easy ones in the queue after this. All right, I'm throwing this in chat. Just throwing it in chat real quick. I'm like technically correct, but this is probably not the right way to do it. So let's see the right way to do it. Also, yeah, dude, ChatGPT 5.1 like blows. Let's see. Okay. Yeah. Yes, this is what we did. This is exactly what I did. Okay. Oh, very cool. Yeah, look at this, dude. What? Yeah, this sucks, bro. What? Okay, so I was doing it the right way. I was, right? Dude, why? Yeah, look at this. There's the 1/4, right? There it is. Oh, man. Square root of 32 over 15? Okay. I think I was very close here, actually. Although I think I had a negative sign wrong here somewhere, right? They kept everything in terms of V2 as well, which is okay. What happened? Okay. I moved P1 over. P2 minus P1 is delta P, right? Or I assume P1. Is that what we're assuming is P1? Oh, they did delta P as P1 minus P2. Oh. Oh, okay. Thanks, troll cats. Integration. Oh no. Don't despair. Okay. We almost got this. Okay. And then, yeah, okay. So negative pi r2 squared delta p, and then this is all over 1 minus 1/16 2 over rho. Is that what they got? They didn't exactly. They're being a little bit smarter with the substitution. Where did I fuck up the 2 over rho on? Actually, one sec. I'll be right back because I need a quick break to get a snack, and we will come back to doing this one. I'm close. I know I'm close on this one. Not yet. Not yet, Sliz. Sorry. Give me a sec. I just need a snack. I was dying. Like I can't do math this hungry. Okay. All right, let's vibe. I think we're gonna go this. Okay. I think I was cool up to here. Let me get rid of this. I think this is all garbage. This is okay, though. And also, I feel like delta P should be P2 minus P1, not P1 minus P2. Right? Delta's usually final minus initial. And then from this, A2 over A1 is equal to a quarter. So V1 squared is V2 squared over 16. Oh, the red box does show P2. I mean, that's if A2 is less than A1. Oh, and V2 is greater than... Okay, yes. You're right. The red box does show that. Yeah. I agree that it's negative. Okay, so that... But still, delta P should usually be written as V2 minus V1. Because it's usually, like, difference in pressure from going from 1 to 2. Yeah. Okay, cool. So I think right here we're still good, right? Yeah. So I let that go over, and then I did this 1/2 row V2 squared minus V1 squared. Wait, we had a stream? We do have a stream, dude. Have one right here. Right now. And then V1 squared is equal to V2 squared over 16. Cool. All right. So then V2 squared is equal to 2 over rho V2 squared over 16 minus delta P. So then I'm just going to multiply through. So that's, yeah, I think the 1/2 makes sense, right? So that's 2 over rho V2 squared over 16 minus 2 over rho delta P V2 squared. Move this over, factor out a V2 squared. You get V2 squared 1 minus 2 over rho times 6 times 1 over 16 is equal to 2 over rho delta P. Divide it out. Everyone writes a different row. Is that true? And then I think what I'm going to do here is I'm going to multiply through by 2 over. I'm going to multiply through by rho over 2. It's just going to make life easier, right? So now this is equal to delta P over rho over 2 minus 1 over 16 equal to V2 squared. That looks pretty different than what chat got, though. Fluid dynamics. these look the same? I get 7 over 16. And I get rho minus 1, dude. What am I doing wrong here? Oh. I see what I did wrong. Yeah, I moved the V1 over before multiplying. Ugh. Algebra. Algebra. Tricky, tricky algebra. Okay. Let's just do it this way. Okay. Sorry. This is 1/2 rho. Then this is V2 squared minus V2 squared over 16. It's equal to negative. dp. Good. Right. Awesome. 1/2 rho. This is 16 minus 1, so that's 15 over 16. V2 squared is equal to... So, I make mistakes too. That's such a silly algebra mistake. Was fucking up so much. Okay. So, V2 squared is equal to 2 times... So, it's 2 over rho, 16 over 15, negative delta P. Where did they drop the 2, though? Oh, the 2's still in there. Okay, cool, great. Okay. So, yeah, so V2 is equal to the square root of 16 over 15 negative 2 delta rho, delta P over rho.
My man.
Cool. That's what they got. I agree with that. And then if you want flux, though, or you need, so, what is it, volume flux is what they want? Volume flow rate. So Q2, which is A2V2, that's going to be equal to pi R2 squared, which is pi times 0.01 squared, times all this. Cool. Nice.
Good job.
There we go. Okay, good. That's that. Thank God. So this is funny that this got marked wrong. So I don't know if this looks like some ancient ass software, if it's actually going to be able to recognize this whole thing in symbolic form. I don't think it's going to. But okay. Estimate the volume flow rate, just plug in. And I'm not going to waste time plugging in, but here, I'll get you what chat says. Kind of assume it's right, maybe. There you go. That's B, and then what was C? Again, check these. You should actually do the numbers. I'm just not going to waste time on the stream doing it. Okay, cool. Nice. Done.
Well done. Well done.
My God. Whose was that? Thor. Thank you, Thor. It seemed easy at first, but like one little algebra mistake just led me down a fucking tunnel of hell. Which again, this is why AI is great, because first of all, I got AI to verify that my approach was correct, but that my algebra was wrong. I was like, okay. That was not Navier-Stokes. They are related though. That was Bernoulli's. All right, next one up is from Willie. Love this. Or do I love this? Or am I gonna regret this? This is why I wouldn't like future math as much as math now. Yeah. Yes, that's correct, Jason. Yeah. Okay. It's going to be long as hell, so it's going to be an adventure to find that once. Yeah, so here's the nice thing, though. Again, you guys live in such an awesome time. This timeline you guys get is, I mean, it sucks in a lot of ways, but it's also great in others. The ability to have AI check your work is amazing. I remember just having to, like, hunt all the time for, like, where's that negative, where's that 0, blah, 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 blah. You can just feed this shit into AI, it'll go find it. And you're like, okay, cool, wow, thank you. What a time to be alive. Yeah, seriously. You still need to do the work, but you just have infinite tools for, like, helping you do it now, which is great. It's pretty dope. Like, that last question, for example, I was getting really frustrated, and then I looked at AI, and I was like, oh, I am doing it right. Okay, so I'm not crazy. But my algebra is trash right now. Mainly because I was hungry. I had to go eat stuff. I was cramping here on the stream earlier. It's like dehydrated. Okay, but let's try to do this one. Could this be integration by parts? Can we make this integration by parts, maybe? Yeah, chug. Yeah, Sam did, yeah. U-sub only. I don't know if U-sub really works here, though. Oh, it does, actually.
Good job.
I remember how this works. This is actually a really cool one. I think you say U is... Oh, man, how do you do this again? Yeah, I think U is equal to 1 plus 2x. Right? So then du is equal to 2dx. But then x is equal to 1/2 u minus 1. Right? If I rearrange it. So, I'm not going to put the bounds on it right now. So I get 1/2 u minus 1. No. Well, yes, actually, no. Yes. And then this is u to the negative 1/2. Right? And then this is like du again over 2 again. So you have a quarter integral of u to the 1/2 minus u to the minus 1/2 du. Right, if I distribute this in, this is the same thing as u to the 1. U to the 1 times u to the minus 1/2 is u to the 1/2. Minus 1 to u to the minus 1/2. Cool. So then you get a quarter. And that's going to be, looks correct. Thanks, Psychode. U to the 3/2, 2/3, minus u to the 1/2 times 2, right? Because you divide by half. Okay, cool. And then we substitute in that u is equal to 1 plus 2x. So I get 1/4. 2/3 u plus 1 x, or sorry, 1 plus 2x. So the 3/2 minus 2, 1 plus 2x to the 1/2, and now I can go put my original bounds, which were 0 to 4. Okay. So, that's a quarter times 2/3 times this part, 4 and 0. So if you put 4 in, you get 1 plus 8, which is 9. And then 9 to the 3/2 is the same thing as the square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. So this is going to be 27 minus me putting 0 in, but 1 plus 0 is 1. Anything to the whatever. 1 to the whatever power is just fucking 1. So great. Awesome. And then we have minus a quarter times 2. And then this is going to be 9 to the 1/2, which is 3, minus 1. Very cool. So, what do we get? 2/12 times 26 minus 1/2 times 2. Oh, that's just 1. Okay, cool. So 52 over 12 minus 1. Is that 4.5? What is that? It's 4 1/3, I guess. Yeah, divide by 3. Or divide by... Yeah, wait. Yeah, divide by 4, sorry. You get 13/3 minus 1. Which is equal to... 10/3? 10/3, nice! Okay, cool, great. That one felt so much better.
That's dope.
I felt so much better about that question. Raven says 2. What's the 2 for? 10/3. Nice.
Oh, yeah.
Yeah, okay. So, yeah, my gut instinct with U sub is to try to always find something so that the derivative of it shows up somewhere else. And that doesn't actually work for this one, right? If this was 2x squared, then we're money. Because I just say, oh, wow, like, U is equal to this, and then du shows up here. This gets a little bit scary because the derivative of 2x is not x. But this is one of these, like, you just trust the process. You've seen this question enough times. You just have to rewrite x in terms of u, and then you end up getting this, and then you get 2 separate exponent things you can deal with. Yeah, this was tricky, dude. This would trick me up as well. Yeah, it's not intuitive for u sub, for sure. I agree. It usually is. Definitely is. Definitely is. I mean, yeah, side code's exactly right. Yeah. Anything inside the square root, just set it to u and just see if it works. Yeah, so MZs, I wanted to do integration by parts, actually, to start, right? I agree with that. I wanted to do this as x times 1 plus 2x to the 1/2. And I wanted to call this, like, u is equal to x, so du is equal to dx. And then you have to integrate this, right? So then you say, like, dv is equal to 1 plus 2x to the 1/2 dx. Or to the negative, sorry, to the negative. You're right, all right. My bad. So then... What is this? V is equal to 1/2 times 2, and then it's like 1 plus 2x to the 1/2. There's a lot of interesting names as the streams go on. I'm seeing, yeah. Yeah, and so then this would be, right? So uv, so it becomes x 1 plus 2x to the 1/2 minus integral of 1 plus 2x to the 1/2 dx. It should be negative. No, because this goes up by a power to 1/2, so you multiply by 2, but then from, like, u sub, because this is 1 plus 2x, you get to divide by 2. This should be negative for sure. Yeah, the YouTube stream is definitely set up for phone. That's how the algorithm works. Dude, trust me, like, I've published things in horizontal and in vertical on YouTube. Vertical wins every day. They really love vertical. Also, it's meant to catch people who are just, like, doom scrolling. They're just like, hey, man, could we learn some shit? Right. So then this, right, becomes the same thing kind of as this. So what do you get? So you get x 1 plus 2x to the 1/2, and then this is minus 2/3, but then divided by 2, and then this is 1 plus 2x to the 3/2. Oh, that's kind of basically what this is, though, right? Yeah, right. Yeah, because this is 1/3, 1/2. Look at that. Well, yeah, this is 1/3. I don't have a half here, though. It's very close, though. Maybe you're alright with the negative, though, MZs. 13 over 54? Well, it's not the right answer. We got 10/3. I wanted to see whether this comes out, though. 1/2 times 2, divide by 2. Yeah, should just be that. Here I got a quarter, though. So... Oh. You're integrating dv. I think something went wrong there. Yeah. Yeah, this integral. Wait. Integral of 1 plus 2x to the negative 1/2, right? You say like u is equal to 1 plus 2x. So you end up getting a 1/2 u to the minus 1/2. So that becomes u to the positive 1/2 times 2 divided by 2. I think you should just get u to the 1/2. We got 10/3. Joel says negative 10/3. Okay, so now I'm starting to think maybe there actually is a minus sign wrong somewhere. Because that's kind of what I get here. Although, wait, no, there's still an x on the outside. Oh, I see. Actually, that messes with it. No, I think this integral is correct. Let me see. Let me just see what the same answer. Sorry. Free fire? No. we attempted yours for a bit. Then I said no to JEE, dude. I said no. All right. This is 4 times 9 to the 1/2 minus 0. Okay, so that goes away. Fembox is right. It's a okay. So this equals to 12, right? From 0 to 4. Oh, it's yeah. You think there's a 2, but now okay. But here's my argument. Okay, if this right, if you do the u sub where this raises up to the 1/2, you have to divide by 1/2, right? That multiplies by 2. But then you also have a u sub of 1 over 2x, which needs to divide by 2. Yeah, JE is very hard. Yeah, no, JE sucks. All right, good to see you, Grant. And then this is minus 1/3. And then this is 9 to the 3/2. Plus... Yeah, that was him. That was his. So, interesting. So, that was 12 minus 9 plus 1/3. Which, yeah. No, look at this. This is 3 plus 1/3, which is also equal to 10/3. Okay, we're good. Yeah, this is the same answer. Yeah, nice. So, 2 different ways to do it. Yeah, you could have done integration by parts. No, there's not a quarter. I think these cancel. Yeah, it's correct. Yeah. I like to think about this. So, u sub is kind of like the chain rule, but in reverse. So anytime like your integrand thing is being multiplied by 2, you got to divide by 2 when you end up doing it. And then the negative 1/2 going to positive 1/2, you divide by 1/2. So it's multiplying by 2. Nice. Okay, 2 different ways to do it. They both work. That's cool. Willy-nilly. Yeah, no, I appreciate the question though. They're fun, man. They're cool questions. You guys ask really good questions. I appreciate learning. Ooh. Oh, this is kind of a tricky one. What's going on here? You have a Diffie Q exam? Oh no, MZs. What's it over? Integrating factors or what? Why am I wrong? Backseat mathing? No, dude, people need to question me more often, honestly. I like it. UU dots. Ooh. The houses are arranged in a 3x12 grid as shown in the figure. That is, the village has 36 houses, one at each grid point. A house is located in row I in column J. Oh, great. Okay. It's 3,7. Oh, wow. Laplace convolutions? Oh, my God. No. I'm going to pray for you. I'll pray for you, MZs. It's actually pretty easy. Okay. Or difference of row numbers plus the difference of their column numbers. For example, traveling from 2-2 to 1-4 takes 3 minutes. A family living in 1-1 wants to visit all the other houses and return to their own home. They use the jet for... Dude, what is this? Taylor Swift, like, going around... What? Dude, what's going on here? Taylor Swift is using a jet to travel between the houses? Y'all seen those memes, right? This is fucking great. Taylor Swift going from one side of her plane to the other side of her plane. Oh, that's fucking hilarious. Okay, whatever. We're using the jet. Find the minimum possible total time for this process. Okay. Let me consider like a small subsector, I guess. And then whenever I see these types of problems, I try to reduce it. Like, let's reduce it to this. Let's say I just had to go here. And it's the difference in the x values and the difference in the y values. Oh, okay. So, for instance, going to here and going to here and then going to here is the same cost, right? Which should make sense, right? Technically, this should be less than doing this and this. But we say it's equal to the difference of the row numbers plus the difference of the column numbers. So, diagonally doesn't get you any points. Right? Doing this, you only get one house and it costs 1, but here you could get 2 houses and get 2. So, I mean, if you went like this, why is there a 2 on its site code? I think it's just x1 minus x0 plus y1 minus y0, right? Or are you talking about like the return trip to go there and back? Good. Okay. So I'm assuming if you went here, went here, went here, went here, went here, then you'd be good. But then this, and so what is your x1? Yeah. If you went to there and back. Okay, so there and back would be that. There and there. I think you want to go visit the houses in a way such that when you get to the last house, you're the closest, right? Like, this wouldn't make any sense if you went like this, and then you had to like double back and go to here and go to here and then come all the way back. Like, that sucks. I think the general strat is you want to go in a way such that the last house is right next to where you want to go home. So, I think you go this way. You go this way. Let's think here. Oh, it's kind of tricky. Oh, wait. Let's say you go this way. And then this way, this way, this way, this way, this way. Right? Is this kind of like what you have to do to snake? Because you basically just want there to be... So the minimum time to hit a house is at least 1, right? That's the lowest that you can do. Oh. Bingo. There you go. Okay, so how many did I do there? Yeah, JH, you're right. I could scale it to what I need. So so what was this? So this was, yeah, exactly, right? Same. This is actually a really cool question. So, that's 11 places this way, right? And then you need to go up one. Let's say you have to go up one there. You have to come down one here. And then let's see what this argument would be. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I gotta refresh. We're almost out of time. One second. Gotta go back. And what is this? This is 11. And this is 12. Okay, so you're gonna have 12 of these. Exactly, 36 is the least, right? Yeah, okay. So that's 11 plus 2 plus 6 plus 12 plus 5. Which is 19, 31, 36. Beautiful. Very cool. Cool question, by the way. Whose was that? That was Astrovic. Yeah, so it's just equal to the number of houses, I guess. Plus your house. Plus your house. Alright, mark that as done. These have been much nicer. These questions have been kind to me. I'm having a better time with these. Again, if you're just reaching us, there's a website, www.actualofficehours.com. There you can enter your username, submit a screenshot of your question. We'll try to go through it in the stream. I know we only have 10 minutes left, but not to worry. If we don't get through your question, it'll get added automatically to our Discord, so make sure go here to join our Discord, and then someone will answer the question in the Discord, whether it's one of my awesome friends and actual educators or a ChatGPT bot we designed. And then if you want to figure out the other times we're streaming, click here on the streaming schedule, and you can see all the other great schedule programmed Twitch streaming events that are here. So go check them out. Let's see what the next one is. So in the queue, so if I click here on queue, let's see what the next queue question is. It's from Equity. I like this. This is nice. You guys are giving me some beautiful questions here. Yo, what's up, Teacup? Yeah, the upgrades are real. Yeah, we stream vertical now. Skitsy, which question is yours, by the way? Oh, is this one? Is this yours right here? Let me do equities real quick, and then I will do yours, because I know you've been waiting for a while. You just want this one right here? Yes? Okay, cool. I'll let you skip, just because you have been waiting for a while. But let me do equities first real quick. Gold, please. I got you, dude. Just give me a second. Let me do this. Okay, two similar right triangles. The ratio of the perimeters is 3 to 5. If the area of the small triangle is 81, what is the area of the larger? Ooh. Interesting. This is kind of a cool question. So two similar right triangles. It might be mn plus 1 if m and n are both odd. Oh, is that for the other one that he asked? Okay. So what? This is also a similar triangle, right? Assume it's like that. What is the area? Oh, okay. So let's say the black one is side A, B, and C. And the green one is like D, E, and F. Okay, so that means D plus E plus F over A plus B plus C is equal to 3/5. That's the perimeters. And then the area... Oh, that's cool. The area of the smaller one is 81. So I know that DE is equal to 81. And so now I want to know what AB is equal to. Ooh. And I also know relationships, actually, between A, B, and C, right? Yeah, this is actually really cool. I think I know what I'm going to do here. I'm going to take this. I'm going to square it. Square. Right? So what's that going to be? D squared plus E squared plus F squared. Plus... Plus, is that 2DE? Am I gonna get 2DE? Is this like 2DE plus 2DF plus 2EF? I think so. Yeah, okay. And then this is gonna get me A squared plus B squared plus C squared plus 2AB plus 2BC, or let's say AC plus 2BC. And that's all equal to 9/25. And then I know that DE is equal to 81, and I'm trying to figure out AB. Yeah, it's okay. If I don't get to the questions in the time, they'll get added to the Discord. The other thing I know is that A squared plus B squared is equal to C squared. And then also D squared plus E squared is equal to F squared. A equals DZ. Roblox was fun. Oh, it's a scale factor. Oh, yeah, fuck this. Sorry. This is a much easier way to do it. Okay. Yep. Thank you. Dude, Zach's the best. Did I shout? I'm gonna shout you out again, Zach. Just thank you for saving me so much time here. Okay, yes. This is equal to a factor. A plus B plus C is technically ZD plus ZE plus ZF. Because if they're similar triangles, the side lengths are a multiple of the original side lengths. Okay, so then we get D plus E plus F over Z D plus E plus F is equal to 3/5. That cancels. Cool. So Z is equal to 5/3. So if DE equals 81, then AB is equal to Z squared DE. Okay. So AB is equal to 25/9 over 81. Which is equal to 2250? I get that right? Yeah. Wait, no. 225. Yeah, nice. Dude, I wanted to do all this. This is not the right way. Okay. Good question, Equity. 25 times 9. Yep, nice. Scale factor. It might have worked. Yeah, I don't know. It was looking kind of rough. Okay, nice. Good question, Equity. All right, last question of the day. I'm gonna help you out, Skits. All right, then let me make sure this one's done. Someone else gave me a 4x4 inverse. Someone's just like trying to give like a gym workout for my math friends. Just like, hey, just do a 4x4 for me. We hit 2100 the other stream. Q Mathematica, exactly. Yeah, like ain't nobody got time for that, dude. Yeah, right. All right, sorry. Let me save this. Did I save this? Sorry, downloads. Equity. Yep. Okay, let's see what Skits has for us. Says f of x is equal to cosine kx, and cool. K is between 0 and 360 degrees. K is a positive. I think x is. I think this is x is between 0 and 360. No. In the case where k is a positive integer, write in terms of k the number of solutions to make f of x equal to 0.5. When k is a positive integer. So I love how it says gold, actually, by the way. What?
Good job.
Do we think this is a typo, though? I'm a little confused by this. Okay, well, cosine of, let's say, z is equal to 1/2 when z is equal to that k should be an x. It's a type of Edexcel A-level question. So we think this is supposed to be x. This is probably a typo here, right? So when z is equal to pi over 3 plus 2 pi n, or z is equal to, oh, it's Pearson. Or z is equal to 5 pi over 3. Right, is that right? Yeah, 5 pi over 3. Plus 2 pi n. Edexcel. Oh, God. Okay. Does this make sense, Skits? Right off the bat, right? Like, you need 60 degrees here for the cosine of that to be equal to 1/2. And so that can either happen here, or it can happen here, which is like negative 60 degrees, which is the same thing as 5 pi over 3. We're stuck in part C. Okay, given that the equation f of x equals 0.5 has exactly 3 roots, state the range of possible values of k. Okay. Exactly 3. No. Yeah. The Darth Vader one, maybe, right? Yeah. Okay. So, multiplying by k. So if k is equal to 1, you have 2 roots, right? Oh, the no one? No. Oh, I'm sorry, Ain. Actually, what's up, Phenomenon? What's up? I know. It's... Albert, was that yours, the fucking 4x4, dude? This is funny, dude. That Edexcel, dude, this thing is... It's kind of annoying, honestly. What? Okay. If k equals 1... that means there's two solutions. If k is equal to, if k is more than that, okay, then you can go around one more time, I guess, right? Yeah. Okay, if k equals 1, you have two solutions. If k equals 2, you have 4 solutions. Reason being is that now going from 0 to 360 in terms of x actually gets you from 0 to like 720. So you can go around twice. So in order to get 3, right? Let's put what the roots would be. So you have here and you have here, right? So you need k to at least equal 1. That'll allow you to do this. And then I need to grab this one as well. So, k could equal 1.5. Oh, I see. So k needs to at least get me an additional 1/6 of a rotation, right? Can you do a different question? Oh, k is a positive integer. No, it says positive constant. Oh, so part A said the case where k is a positive integer. Sorry, I'm doing part C here. I think k can be a decimal here. This question is blasphemy.
You got messed up,
Okay.
Aaron!
Okay. So the cool thing is that like as you increase k, you like increase the effective amount of rotation you can go around. So if I need to hit this one, and then hit this one again, I need to go an additional 60 out of 360 degrees. So I need to go an additional 1/6. So k needs to be at least 1 1/6, which is 7/6, right? No, these are real solutions. That's okay. All right, and then I can keep going around until I get to here. Because if I hit that, then I hit the 4th solution. Exactly. So I need to go from 60 degrees more to 300 degrees more. So 300 over 360 is equal to divide by 3, 10 over 12, 5 over 6. So I can go an additional 5/6. So that would be k is equal to 11/6. Okay. So yes, the range of k is equal to 7/6 to 11/6. Does that make sense, Skits? This is Edexcel. Why is it the gold level, by the way? What? Let me check the answer one sec. Okay, waiting. We'll wait for it.
Whoa, whoa, whoa. Oh la la. Oh, well. King in the castle, king in the castle. Have a chair, I have a chair. Oh, go do this. King in the castle. Whoa, whoa, whoa.
We're still waiting for Skitsy to check.
Oh, king in the castle, king in the castle. Have a chair, I have a chair.
It says it can equal 7/6. Yes. Yeah. Sorry. It can equal 7/6, but it can't equal 11/6. Yeah, sorry. Yeah, it has to hit this one for 3, but then you want it to not hit this one. Because then you would hit 4. Yeah. Does that make sense? Nice. Okay, cool. I gotta end the stream out pretty quick here, though.
That's dope.
Good question, Skits. Appreciated it. What was that? It was number 5. Yeah, you're very welcome. Nice. Okay, cool. All right, let's end the stream. All right, thank you, everyone, for coming to Actual Education Office Hours. Appreciate all the awesome questions we had today, minus the JEE ones. Yeah, awesome. Again, if you just found us on any of the other platforms and you haven't like seen us before, we do this 5 times a week. So make sure to go to the website. It's called actualofficehours.com. And there you can see that we have a calendar. I'll show you right here. And on that schedule, you can see all the other awesome times. Do another question for the sport. Unfortunately, I have to go. Like I have other students I have to teach right now. But we will be on tomorrow. So tomorrow, Zach's going to do math chat on a topic. So that's cool. I think he's doing Laplace transforms. So make sure, go check him out on Twitch tomorrow morning. And then we will also be helping out with math and science questions tomorrow afternoon. Also, make sure to go watch us, follow us on Twitch, follow us on YouTube, join our Discord if you want to, all the answers to everything we did today will be posted there. And anything that I did not get to, because I know there's still a couple questions here, these will get put into our Discord, and other people might choose to, tackle them. Or at least we'll have an AI bot go through them in 2 days. Great. Okay, if you're watching us on Twitch, we're going to go raid someone real quick. It's our way of showing support to other people who stream on Twitch. So let's see what we got. Who are we gonna go raid? Who's on right now? Following. Robineering. Some co-working. Dude, I've met so many cool people. I met this person, Trash. They're really cool. Trash is a really cool person. Curly's playing video games. Wicked. Building a sketchy e-bike using entirely Temu parts. This sounds dope. Yeah, you guys want to see this? This sounds cool. Okay, go check out this streamer. I guess they're trying to create something. They got a lot of people on it. All right. That being said, I hope you guys had a lot of fun. We will see you guys tomorrow. Peace.